Imagine waking up one morning in a world where energy is no longer a problem. A world where cities never worry about power shortages, where electric vehicles travel thousands of miles without needing frequent recharging, where homes generate much of their own electricity, where factories operate with almost no carbon emissions, and where humanity finally gains access to energy sources so abundant that the idea of an energy crisis becomes a distant memory. At first, it sounds like science fiction, a futuristic vision from a movie, a world powered by technologies that seem decades away. But the reality may be closer than most people realize. Because right now, in laboratories, universities, research centers, and technology companies around the globe, scientists and engineers are working on exactly that future. A future powered by entirely new forms of energy. A future that could transform civilization itself. Energy has always been one of the most important forces in human history. Every civilization has depended on its ability to access and control energy. Thousands of years ago, humans relied on muscle power.
Human muscles, animal muscles. Then came fire, wood, windmills, water wheels, coal, oil, natural gas, electricity, and nuclear power. Each breakthrough changed society. Each new source of energy unlocked possibilities that previous generations could barely imagine. Coal fueled the Industrial Revolution. Oil transformed transportation. Electricity connected the world. And today, humanity stands at the beginning of another energy revolution. Perhaps the most important one yet. Because the world faces a challenge unlike anything previous generations encountered. The global population continues to grow. Cities continue expanding. Artificial intelligence requires enormous computing power. Data centers consume vast amounts of electricity. Millions of electric vehicles are entering the roads. And billions of people seek higher standards of living. All of this requires energy. More energy than ever before. At the same time, humanity faces another challenge: climate change, air pollution, environmental degradation. The consequences of relying heavily on fossil fuels are becoming increasingly difficult to ignore. The challenge is no longer simply producing electricity. The challenge is producing enough electricity while minimizing environmental impact. This challenge has launched one of the greatest technological races in history, the race to build the energy systems of the future. And perhaps no future energy technology captures the imagination more than nuclear fusion, often called the energy of the stars. Every second, the sun produces unimaginable amounts of energy, not by burning coal, not by burning oil, but through a process known as nuclear fusion. Inside the sun's core, hydrogen atoms collide under extraordinary temperatures and pressures. When they fuse together, they release enormous amounts of energy. This process has powered the sun for billions of years. For decades, scientists have dreamed of replicating it on Earth. If successful, nuclear fusion could become one of the most revolutionary energy sources ever created. The fuel required for fusion is abundant. Some of it can be extracted from seawater. Fusion produces no carbon emissions during operation. It generates significantly less long-lived radioactive waste than conventional nuclear reactors. And theoretically, it could provide energy for millions of years. It sounds almost perfect. But there is one enormous challenge. Fusion is extraordinarily difficult. To create fusion reactions, scientists must generate temperatures exceeding 100 million degrees Celsius, hotter than the core of the sun itself. At these temperatures, matter becomes plasma, a superheated state of matter that is extremely difficult to control. No ordinary material can contain it. Instead, scientists use powerful magnetic fields to hold the plasma in place,
preventing it from touching reactor walls. One of the largest fusion projects in history is the international reactor known as ITER. Its goal is simple to describe, but incredibly difficult to achieve: produce more energy from fusion than the energy required to sustain the reaction.
If successful, ITER could pave the way for commercial fusion power plants capable of delivering clean, abundant energy on a global scale. Yet fusion is only one piece of the future energy puzzle. Another technology is already transforming the world today: solar energy. Every second, the sun delivers enormous amounts of energy to Earth. In fact, the sunlight reaching our planet contains far more energy than humanity currently consumes. The challenge is capturing it efficiently. Solar panels have improved dramatically over the past few decades. They have become cheaper, more efficient, and more accessible. Researchers are now developing next-generation materials, such as perovskites. These materials could create solar panels that are lighter, cheaper, and potentially more efficient than today's silicon-based designs. Imagine windows that generate electricity, building walls that function as power plants, vehicles that partially recharge themselves through sunlight. These ideas are no longer science fiction. Many are already being tested. But solar energy faces a familiar challenge. The sun does not shine all the time. Night arrives. Clouds appear. Weather changes. This is why energy storage is becoming just as important as energy generation. And that brings us to one of the most important technologies of the future: advanced batteries. Today's electric vehicles primarily use lithium-ion batteries, a technology that has revolutionized electronics and transportation. Yet researchers are already developing the next generation: solid-state batteries. Unlike traditional batteries, solid-state designs use solid materials rather than liquid electrolytes. The potential advantages are enormous: higher energy density, faster charging, improved safety, longer lifespan. If these batteries become commercially successful, electric vehicles could travel significantly farther while charging much faster than today. But batteries may not be the only solution. Another promising candidate is hydrogen. Particularly green hydrogen. Hydrogen is the most abundant element in the universe. When used as a fuel, its primary byproduct is water. No carbon dioxide, no harmful emissions, no smoke. The challenge is producing hydrogen efficiently. Today, much hydrogen production still relies on fossil fuels. Green hydrogen seeks to change that, using renewable energy sources such as solar and wind power to split water into hydrogen and oxygen. If the process becomes economical at large scales, hydrogen could transform industries that are difficult to electrify: shipping, heavy manufacturing, steel production, long-distance transportation, and even aviation. Meanwhile, wind energy continues advancing rapidly. Modern wind turbines are far larger than those built just a few decades ago. Some stand taller than skyscrapers. Their blades stretch longer than the wings of commercial aircraft. These massive machines can generate enough electricity to power thousands of homes. Particularly exciting is the growth of offshore wind farms. Far out at sea, winds tend to be stronger and more consistent. This allows turbines to generate electricity more reliably. Countries across Europe, Asia, and North America are investing heavily in offshore wind infrastructure, creating giant renewable power stations visible from space. But the oceans themselves contain another enormous source of energy: waves, tides, and ocean currents. Every day, vast amounts of water move across the planet, driven by gravity, wind, and the Earth's rotation. Engineers are developing technologies capable of converting these movements into electricity. Although still emerging, ocean energy holds tremendous potential, especially because tidal patterns can be predicted with remarkable accuracy. Then there is geothermal energy, energy from within the Earth itself. Deep beneath our feet lies an immense reservoir of heat.
heat generated during the formation of our planet billions of years ago. In certain regions, this heat can already be harnessed to produce electricity. New geothermal technologies may eventually allow access to underground heat sources in locations previously considered unsuitable.
And then there are ideas that sound almost unbelievable. Space-based solar power. The concept is simple yet ambitious. Place massive solar arrays in orbit around Earth, above the clouds, above the atmosphere, exposed to sunlight almost continuously. The energy would then be transmitted back to Earth using advanced wireless transmission systems. No clouds, no nighttime interruptions, no weather-related reductions in output. Although still experimental, several countries and organizations are actively exploring this possibility. If successful, it could fundamentally change global energy systems. Yet perhaps the most important lesson from history is that energy transitions rarely happen overnight. Coal did not immediately replace wood. Oil did not instantly replace coal. Electricity did not immediately transform every industry. Each transition required time, infrastructure, investment, innovation, and public acceptance.
The future energy system will likely not depend on a single technology. Instead, it will be a combination of many. Solar energy, wind power, advanced batteries, hydrogen, geothermal systems, nuclear fission, nuclear fusion, and technologies that may not even exist yet. Together, these innovations could create a cleaner, more resilient, and more sustainable energy network. Because ultimately, energy is not just about electricity. It is not just about technology. Energy shapes economies, societies, industries, and civilizations. It determines how people live, how countries develop, and what possibilities become achievable. One day, future generations may look back at fossil fuel power plants the same way we look at steam engines today, as technologies that once transformed the world, but were eventually replaced by something better. And when that day arrives, they may realize that the greatest energy revolution in human history did not begin with a single invention. It began with countless scientists, engineers, and innovators asking one simple question.
How do we power the future? And the answer to that question is being built right now. Quietly, patiently, one breakthrough at a time.